Today let me teach exercise 3.1 from chemical kinetics chapter. The question says, from the concentration of the C4H9Cl, which is a butyl chloride, calculate the average rate. So the equation is C4H9Cl plus H2O gives C4H9OH plus HCl. Here in question they have given the time limit and also the concentration. Here this is the initial concentration, this is the final concentration, this is the initial time, this is the final time, and the question we are asked to find is the average rate, which is, this is what we need to find, but I have given the answer first. So let me show how I got this. So here is the formula CH4Cl T2 minus CH4Cl T1 by T2 minus T1, which is the final concentration minus initial concentration by T2 minus T1. That is final time by initial time. This process is known as hydrolysis of the butyl chloride. So let me do how I got this answer. So first the final concentration minus the initial concentration by final time minus the initial time. If I do this, I got the answer to be 0.00019. But the concept that we learned in our 11th standard is significant figure. So using that, I want 1.9. For getting 1.9, I have to multiply into 10 to the power of 4. So 1.9 into 10 to the power of minus 4 is what I got. 1.9 into 10 to the power of minus 4. But in question itself, we are asked to find the R average into 10 to the power of 4. So if the answer I got is somewhat like 1.9 into 10 to the power of minus 4 only. But in question, we have to multiply 10 to the power of 4. So this and this will get cancelled and finally you will get 1.9. This is how I got 1.9 here. And similarly, we have to get all the answers like this. But in a textbook, you have got one graph here stating that the graph is keep on decreasing. With at a particular instant, if you see the tangent to the slope, you will get the instantaneous speed. So let me explain what is instantaneous speed. The average rate cannot be used to predict the rate of the reaction at a particular instant, as it will be constant. Average rate, if we say, it will always be constant for a particular time interval. For a particular time interval, average rate will keep on be constant. So, in order to predict the rate of the reaction, instantaneous rate is very important. That is, the rate at a particular moment of time. The average rate at the smallest time interval is known as instantaneous rate, that is delta t approaches to 0. Here if you see, R average is equals to minus delta R upon delta t, delta p upon delta t. As time interval approaches to 0, it is what is known as instantaneous rate, that is average rate at time interval nearly delta t is equals to 0. R instantaneous equals to minus dr upon dt, that is dp by dt. That is differentiation, dr by dt or dp upon dt. Here if you see, the slope of the tangent gives the instantaneous rate. For finding at 600 second, I have to do here, the 600 is in between 800 to 400. So concentration is from here, if you see, if you spot, you will get 0.01.